What is up, everybody? Welcome back to another weekly live stream from Scalar Learning. And I just want to first off apologize to everybody because I didn't get to do a live stream last week on SAT Khan Academy problems. I'm just making sure my audio is working here. I didn't get a chance to do a live stream last week, and I apologize for that. Hold up, let's see. Is my audio working? Doesn't seem to be working. Let's just make sure. All right, can you guys hear me? All right, it seems like it's working. Here we go. All right, and this one is... Hold on one second. All right. So hopefully you guys can hear me. It seems like that is the case. All right, so I'm going to continue here. Oh, I see what's going on. All right, cool. We are good. All right, let's start. So today we are continuing with the SAT Khan Academy problems. And again, apologies for last week. I was out of town on a school field trip. And today, luckily, I have a lot of work to do, so I actually took a half day, which is why I am able to broadcast this quickly during the daytime. And I'm going to be working on the next math music video after this, which is really cool. Hopefully it should be out next week. And we are solving systems of linear inequality word problems. So without further ado, let's do it. And as always, I'm seeing these prompts for the first time, so that is part of the fun. So it says, a tennis club is organizing group lessons. The club supplies 40 new balls for each player, which cost $1 each. Okay. Each player pays $300 for the lesson. Okay. And the club must pay each instructor $1,000 for conducting the lessons. Okay. This is the instructor. And there must be at least one instructor for every 6 players. Very complicated. All right. Which amount of players and instructors meets these requirements and still gives the club a net profit? Okay. It looks to me, so every player gets 40 balls, which each cost $40. So every player, it costs the club $40. And then the lesson costs them $1,000 to get the instructor. And then they're paying $300. So if we get $1,000, the club loses $1,000. Excuse me, not $1,004. That's $1,040 per player. So 1,000. Let's say for 6 players, that's the most instructor can do. The club is losing $1,240. Okay, and if we have 6 players times 300, that's 18. They're definitely making money. So now let's just go through this here. We've got 6 players and 2 instructors. So that is 6 times 40, that's $240. And then we're paying $2,000 for an instructor, for each instructor. And then we're getting $1,800. That's definitely a loss, right? We're paying $2,240. And then this is the profit. This is what we're making. It doesn't cover the loss. So A is out. Let's put these down here. A, B, C, D. A is out. All right, now let's look at B. 10 players, 3 instructors. So we're losing $3,000. We're gaining $3,000 because 3 instructors cost $3,000. 10 players, we make $3,000, and then we also got the cost of the balls. That doesn't work. 13 players and 2 instructors. This looks like it's gonna work. So 13 players. That's $300 a person. So we're making $3,900, and then we're losing $2,000 to pay the instructors, plus 13 times 40. This is a calculator problem, but we could do this mentally. That's 40 times 13 is 520. So we're spending $2,520 and we're making $3,900. It's definitely we're making money. So this works. So we can go ahead and choose C. Because if you look at the incremental, this one we're making an additional $300, but we're losing another $1,000, right? And still gives the club a net profit. So this one, hold on, 16, 4,800. We're losing 3,000, and we're losing 3,480. We're still making 4,800. Oh, but that last one, It doesn't. No, it does work. One instructor for every. It looks like we make money from both of these. Let me just make sure I'm understanding this right. It's definitely got to be C. So we've got $40 times 16, so it's 48, 480. Let me just quickly calculate this. 480, we're losing. So, and plus 3,000. And then they're making $300 per lesson. Right, 300. Interesting. All right, so I'm going to be curious to see. I believe this is the... Oh, I see why this one's wrong. You can't do 2 instructors and 13 players because this one violates the requirement of 2 instructors, 1 instructor to 6 players, so it's actually D. And D is right. That's what it says. See, we need at least 1 instructor for every 6 players. I almost got that wrong. That's crazy. All right. Let's go on to question number 2. This is no calculator. A bottle weighs 50 grams and holds up to 2 liters of liquid. 50 grams and holds up to 2 liters of liquids. A chemist is filling the bottle with X grams of ethanol and Y grams of water. Ethanol has a density of this and water has a density of this. The chemist wants the mass of the bottle to be less than 1,800 grams. Which of the following systems of inequalities best models the situation described above? All right, this is tricky. So, first of all, we want this to be less than 1,800. So, we want less than 1,800 grams. So, ethanol has a density of 789 per liter. Let's figure out what's going on. So first of all, we know that the volume is going to be less than or equal to 2, and I think all of these guys have that. Now the question is, which of these equations are right? It's either 789x plus 1,000y is less than or equal to 2, or it's this whole craziness where x and y, x is the amount of grams. So what do we do to convert First of all, what is density? Density equals equals mass over volume. So if we want to convert this to just volume, because that's what we've got here, right? We're trying to get it to less than that, to less than 2 liters. Then what we need to do is we need to actually flip this. We need to do, if we do mass over this, we get volume. So if we put the mass divided by the density, if this makes sense. So what I'm saying is, if we do mass divided by density, it's really mass times the reciprocal. These guys cancel out and you got volume. So which one is mass divided by density? It looks like B or D, right? So we've got X is our... Well, let's see here. What does it say? X is our mass, grams, over its relative density, which is 789 for ethanol. And these two are the same. So now we can cross off A and C. Boom, boom. We're left with B or D. So now the question is, which one of these equations are right? Is it X plus Y is less than 1850 or X plus Y is less than 1750? Now those are the masses. Now, see, they say they want the chemist wants the mass of the filled bottle to be less than 1,800 grams. So it's not. It's actually, they don't put 1,800. They put 1,750 or 1,850. The question is, which one is which? It's this part that's the differentiator. The bottle already weighs 50 grams. So the mass of the bottle, the mass of the entire thing should be 1,800, meaning the mass of the ingredients needs to be 50 less than 1,800, which is 1,750. And that's why A is the right answer. These are, oops, did I do that wrong? Oh, shoot. I did that backwards. The mass of the bottle, including the 50. So they said just the filled bottle is, wait, hold on. Oh, darn it. I meant to choose B. I chose, yeah, this was right with 1750. Okay, so that was correct. And I had eliminated A and C, but I accidentally chose A. So, yeah, it was B. and it is less than 1750. So you do indeed take those 50 grams away. See that? You got to double check everything. Hopefully on the test you actually physically cross off A and C so you won't make that mistake. But yeah, it's this guy. All right, let's move on to question 3. Darren is traveling abroad with a $25 credit card, which was a gift from her grandmother. The rate call to Japan, where her boyfriend is living, is 19 cents per minute. 19 cents, I'll multiply this by minute. The rate call to Japan is 19 cents. Her family is in Turkey, where the calling rate is 12 cents per minute. This is in Turkey. This is in Japan. Darren promised her grandmother she would spend at least 30 minutes of her time on keeping in touch with family. And that's to her family's in Turkey. So Turkey has to be at least 30. Which of the following system of inequalities represents a relationship between J, the number of minutes Darren could call Japan, and T, she could call Turkey. Was a gift from her grandmother. The rate to call, okay. The rate to call Japan, where her boyfriend is living. Her family is in Turkey, where the rate to call is 12 cents per call. So Darren has promised her grandmother she'd spend at least 30 minutes of her minutes on keeping in touch with family. So what I'm feeling is like these don't look right because it should be Turkey that should be greater than or equal to 30, not Japan, right? They didn't say, unless you're including the boyfriend as family, which I don't think they are, A and B should be eliminated. So those guys are out. Now let's look at these inequalities. So we're only talking C and D, so I don't make the same mistake I made last time. So now what's the relationship here? And she's got $25, right? So $25 is the max. And it looks like what we're doing is 0.19 minutes to Japan plus 0.12 minutes to Turkey have to be less than or equal to 25, which is basically, let's see, oh, I see. I think it's actually going to be C. That's a calculator question. I'm going to show you why in a second. So what they've done is they've isolated T. So that's what we have to do. So let's go ahead and isolate T. Let me remove this stuff here. Oops. Sometimes they do this just to see if you have one additional layer of understanding. So I'm going to multiply, I'm going to subtract, I'm going to subtract 0.19J from both sides. And we got 0.12 T is less than or equal to 25 minus 0.19 J. Then they divided both sides by 0.12. Okay. So this becomes T is less than or equal to, now let's use a calculator, 25 divided by 0.12. It's 208.3. Did I do that right? Roughly 208. All right. So we'll say 208.3 minus, and then 0.19. 0.19 divided by 0.12 equals, rounded up to 1.6. So they're rounding, I guess. 1.6 T. Or sorry, 1.6 J. And there we go. So rounding like this, yeah, because they're rounding to the nearest minute. So it's 208 minus 1.6 J. So you can see the C is right, but C seems really weird when you first look at it. That's all they've done. They've isolated T. Okay, let's go to question number 4. It says Manoj runs a business at a baseball stadium. This month, with a budget of $17,000, Manoj buys P pounds of peanuts at 1.1 and pays his salesperson people $200 each. 200 times S. All right, so this is my cost. These guys added up as my cost. There are S salespeople in total, and it is predicted that each can sell a maximum of 1875 peanuts this month. That means the number of pounds. All right, so let's think about this. Each one can sell, so pounds. Wait, let's think about this. He buys P pounds, right? So 1875, each one can sell, so 1875 times S. So each one sells that. That's the amount at the most that they can sell. So that means the pounds that he should buy should be less than or equal to this, because this is at the very cap. So he should sell no more than this. All right. And then this guy, this and this, with a budget of 17, this and this has to be less than or equal to 17,000. You see I'm slowly constructing this, and these are not easy problems. So let's now start going through some of these and see if any of these make sense. Notice will not buy more peanuts than what he predicts the salespeople can sell. All right. So let's take a look. I'm going to start by eliminating the second equation first. We want P is less than or equal to 1875S. So this is good. P is great. Wait a minute. All of these are wrong. Only D is right, because D is the only one that has the second equation correct. So unless I'm reading this incorrectly, the amount of peanuts should be less than or equal to 1875 times S. Let's just quickly make sure the top equation looks right. 17,000, which is what I have here, is greater than or equal to. Yeah, so this is pretty good. So this is weird. Luckily, this second equation was unique. The top equation looks like the top equation is unique too. So this is a case where if you get either of these right, you would have been good. You don't need to solve both of them. And yeah, we are correct. All right. Last but not least, number 5. A used car dealer has 20 vehicles, all cars and trucks. He would like to 20 vehicles, okay? He would like to paint and clear coat as many of them as possible with 260 liters of paint and 300 liters paint, 300 liters of clear coat. It takes 13.2 liters and 9.5 liters of clear coat for a car. 13.2 paint, 9.5 C for a car, and it takes 1.5 times those amounts for one truck. Okay, interesting. So given the relevant equations graphed to the left, which of the following could be the amount of cars and trucks that received paint and clear coat? So I think there's a few different equations here. So we need to figure out what's going on, right? So we have how much? So he's got 300 liters of clear coat and 260 liters of paint. So let's try and decode what these equations are. First of all, C plus T, this is cars plus trucks. This is our C plus T equation. We obviously have to be below this line, because when we're above this line up here, we're above, this is not possible because he has 20 vehicles, right? And this would be what we would do to, this looks like we're maximizing the clear coat. So there's way more we have more clear coat than we need, all right? So we don't have to worry about this. But what we do have to worry about is, the safe zone is underneath this line. And it's got to be underneath this line. The key here, okay, so now I'm realizing what's going on. We've got to be, we can't be beyond the least line, the smallest line. And it looks like what our limiting factor is the paint. And that makes sense because look, the amount of paint we need for each car is more than the clear coat. And we have more clear coat. So the amount of clear coat isn't the limiting factor, it's the paint. So we have to be under this line. We're already under these other two. So anything on or below this line is good. So let's check these values out. 10 cars and 6 trucks. 10 cars and 6 trucks. That actually works. We're under all 3 lines. We're good. Let's just look at the other one. 6 cars and 10 trucks. We're just above it. That's out. 14 cars and 11 trucks. 14 cars, and we're definitely way up here somewhere. That's no good. 11 cars and 14 trucks is up here. So also no good. So you can see it's just that guy. Okay. So there you go. There is our SAT Khan Academy video for today. And again, sorry we had the hiatus last week. I was up in Yosemite. I wasn't able to get a connection to even shoot a video. So it is what it is. But we're back on for every Wednesday live streams for Khan Academy. I hope this was helpful, and make sure if you want to get notifications and see these every week, keep working on your math, subscribe. If you have any questions about how I did something or how I solved something, make sure to leave a comment and I will get back to you as soon as I can. Thank you guys so much for joining, and don't worry, if you're looking forward to that next math music video, it's coming out next week on long division. About to work on it right now. Thank you guys so much, and I hope you guys have an awesome day.